conference will now be recorded.
So guys, I'll clarify your doubts technically. What are the doubts you are having? I'm going to clarify at the end of the session. First, let us go through conceptually what are the some important terminologies which we follow in and data engineering projects. The first, guys, try to understand from the very basic, from the very first level. Let us start at the very ground. So make a question yourself, guys. And what is big data? Guys, make a question yourself. What is big data? So the name itself specifies just a single line answer, guys. Anybody, even in the question itself, you have an answer. Can anybody say, guys, what is big data? With the
Large
question
amount of
itself.
data.
Yes, yes, that's it. The massive volumes of data. These
Large
massive volumes of data measured in terabytes and petabytes. Generally, guys, gigabytes and megabytes are not termed as a big data. Yes, so big data means a massive volumes of data that generates exponentially with the time and measured in terabytes and petabytes of data. So, and single line answer, guys, let us say, and okay, then you guys can understand. Okay, at the end of the session, I'll come to the conclusion that what are the different Microsoft Azure services that are playing a key role in developing a data engineering project on Microsoft Azure cloud computing platform. So guys, here try to understand big data means, okay, massive volumes of data, guys, massive volumes of data, okay, measured in, okay, terabytes or petabytes. Terabytes or petabytes of data. Good. Now here and the next, the one more very important question, guys. Okay, now this is what the uh, introductory and the start point for the data engineering. Yes, and one more question. Make yourself, guys. What is big data analytics? This is a very common terminology we are going to learn. Big data analytics. Analytics. Okay, or analytica or analytics. Fine. And and can you make try to attempt that? Anybody having at least an idea on? Can you make an attempt on this? What is big
after
data analytics?
after processing the huge amount of data, we have to analyze the data for the stakeholder business to find a particular KPI like that.
Okay, very good. So, guys, here, understand, sir. If you want to let us more elaborate on big data analytics, if you want to make analyzing what is big data analytics, okay, sir, here, remember, data analytics or big data analytics is a process of, it's a process of collecting the data. It's a process of collecting the data, collecting the data, processing the data, and analyzing the data. Analyzing the data as per the business needs. Okay, so here, what are the different phases are going to be involved in big data analytics, guys? First, remember, you need to, okay, collect the data. So I'm writing simply collecting raw data. We guys call it as a collecting raw data from, okay, different, okay, source systems. Source systems, collecting the raw data. Raw data is nothing but, guys, the transactional data. Raw data is nothing but an original transaction data which may contain some anomalies or which may contain some, okay, impurities present in the data. Guys, impurities means like example, if you consider what kind of impurities, okay, a raw data may contain. A raw data is nothing but, guys, original transaction data. This original transaction data may contain some anomalies. Anomalies means present some impurities present in the data. Yes, the data may not be fit for analyzing the data and accurately making the decisions. Okay, so first of all, okay, in data analytics project, first you are going to collect raw data in a different formats, maybe in a file format, in a tabular format, or in semi-structured format like a JSON format or XML format. Yes, the data gets collected in various, okay, formats. Okay, that's called original format of the data that present in the source system. A source system is nothing but, guys, a source system. Okay, different types of source system means the source for generating the data. Okay, what kind of different applications you are using. A source system always represents what kind of an application is used while generating the data. It may be a CRM application, it may be an ERP application, yes, or it can be any business application. Yes, so every business application generates the data and depends on the domain, like banking and finance domain, or tourism and travel domain, and e-commerce, sales and retailers, automobile and manufacturing, clinical and healthcare. Yes, so different application in every domain. In every domain, the different applications gets present, and those applications are used to operate your business. While operating the business, the data gets generated. This data, actually we call it as transaction data, which is an original data, and the data may contain, okay, some anomalies. Okay, maybe those anomalies can be, and data cleansing, we do the data cleansing, like handling duplicates and handling missing or null values. Yes, and deleting the rows for the missing values, or fill the rows with the default values, standardizing the data formats, checking for data consistency. Lot of things will be there in the raw data. Okay, so, and the once you collect raw data from the different source systems in a different, okay, formats, maybe, guys, here a format is like, maybe I'm telling few file formats I'm writing, guys. Maybe raw data maybe gets available in CSV file format, and some and sometimes your raw data may be provided in the form of JSON, okay, file format, or sometimes maybe your data may be available in one more semi-structured file format like XML file format, or sometimes maybe data gets available in the form of Excel, okay, sheets, Excel sheet, or sometimes your raw transaction data may be provided in the form of, okay, and tables, tabular data. You can also say tabular, okay, data, nothing but, guys, tabular data is nothing but, in bracket you can say, databases. Okay, and sometimes data maybe even comes from, okay, uh, okay, and the REST API data, representational state for REST API data, okay, REST API data. Okay, data may also comes from the REST API, or, and sometimes, and data maybe comes from some applications, ERP applications. Okay, so data maybe come from the different source systems and different formats. Once the data is collected, once the raw data is collected from the different source systems, okay, the raw data needs to be, okay, the raw data needs to be validated. You need to validate the raw data. So here and see, and here the next phase is guys validate raw data. Guys, remember validate raw data. Okay, and validate raw data to identify data anomalies. Data anomalies. Okay, nothing but data impurities needs to be identified, guys. You need to identify the data impurities. What kind of impurities that present in the data? Not every data is okay fit for okay analyzing the business, and not every data may not be required for analyzing the business. So as per the business needs, as per the business needs, you need to identify that what kind of data, okay, what kind of impurities that present in data. Okay, and anybody can give you some examples of what are the data anomalies? Yes, anybody?
Duplicates missing values.
Very good, very good. So as remember what kind of anomalies, okay, anomalies generally refers to, guys, you know, data anomalies generally we refers to any unexpected or inconsistent or unusual any data points or data patterns. Yes, see guys, unexpected, inconsistent or unusual data points. Okay, that means that also, okay, um, so we can call it as outliers, and actual terminologies, guys, outliers. Okay, what do you mean by outliers means? Okay, um, outliers means, guys, any data, any data which represents a value from the deviations. Okay, so expected value some. Okay, if expected value is a 10, but it's showing the value of 300, so there is a lot of deviation. Expected value and the actual values have a lot of difference. So these are all called data anomalies. So guys, here and try to understand. You can say outliers and means unexpected values. Outliers are simply say unexpected values, not the actual values. Okay, so these anomalies, guys, I think spelling will change. Okay, these anomalies, okay, nothing but here, okay, the first one I can say, and duplicates, okay, and otherwise missing values, and inconsistent data, and you guys can also say outliers, guys. You can say outliers. Okay, what do you mean by outliers? Outliers. Okay, and see, guys, these are all okay or comes under validating. Once you validate the raw data, once you validate the raw data to identify data anomalies, just data quality checks, guys. Okay, this phase is actually called it as, guys, uh, data validation phase. means identifying the data quality checks. Okay, data validation phase. Once you identify the data validation phase, the next you are going to start, okay, processing the data. That once you identify some anomalies, to bring the data to consistent format, come on, to bring the data to consistent format, or to eliminate the duplicates, that's called data cleansing and standardizing the data and eliminating the outliers. Okay, for that you are going to process your activity. So guys, and that's okay. So the next phase in data analytics, guys, data processing. Data processing, of course, you guys can also call it as a data transformations. Data transformation. And this is a major activity, guys, where you people are going to write the logics, where you people write the logics, where you write the logics to process the data. That where you write the logics to process the data processing. Sir, here in data processing, you have a now I'll give you what are the different data processing paradigms. Okay, you have, guys, okay, monolithic, okay, data processing paradigm. This is a very traditional, okay, data processing paradigm, guys. This is a very traditional data processing paradigm. And actually, this monolithic data processing paradigms are used, okay, at the to process very low volumes of data, like megabytes and gigabytes of data to process. And we are going to use monolithic data processing paradigm. Here only a single compute, a single machine, guys. Here I'm writing a single machine is involved. A single machine is involved in processing the data. A single machine is involved. The name itself saying monolithic, means a single machine gets participates, okay, in processing the data. As the volume of data increases, guys, as the volume of data increase on the machine, ultimately load on the machine increases, it takes more time to process the data. Yes, certainly it will take time. It will take time to process the data. It will take time to process the data. Even sometimes, guys, if the volume of data increased and the machine even gets choked, and so lot of, okay, issues, technical issues gets arises when you try to process very huge volumes of data on a single machine. One is, it may take more time to process the data. Sometimes even machines will be choked. Okay, choking means it's stopped due to some hardware related issues. So monolithic data processing generally, okay, sorry, here I'm writing, okay, and in monolithic, okay, I just write, okay, single machine, okay, single machine. And the next, and see, recommended for low volumes of recommended for low volumes of data. Okay, recommended for low volumes of data. It's one of the very traditional and early adoptions of early adoption. Okay, early adoption in the sense, it's a very, and around 15-20 years back, the organization have very limited volumes of data only, okay, used to maintain. So that limited volumes of data to process, generally monolithic kind of data processing paradigms are going to be recommended. As volume of data is increased, guys, okay, now there is and latest and more advanced data processing paradigm, that is called Okay, distributed data processing, distributed data processing paradigm. Sir, distributed data processing paradigm. Here, guys, the name itself saying distributed and distributed is a more advanced data processing paradigm where the multiple machines are involved in processing the data. Where multiple machines are involved in processing the data. Yes, so just a minute, sir, 1 minute. So everybody just wait for a minute. Okay, and come back, guys, and sorry. And here, guys, the name itself saying distributed data processing or distributed computing. Sir, here there are multiple machines, guys. There are multiple machines. Okay. Sir, multiple machines will be involved. Multiple machines. Multiple machines gets involved. Multiple machines gets involved. And the second thing, okay, data is okay. And say incoming data is divided. Sir, incoming data is divided into small chunks. Incoming data is divided into small chunks called partitions. Incoming data gets divided into small chunks called partitions. Now, the partitions are distributed. Partitions are distributed. Okay, distributed across, okay, multiple machines. Partitions are distributed across multiple machines. Partitions are distributed across multiple machines. Okay, and next point, okay, and data is parallelly processed as parallelly. Guess data is a parallelly. Data is parallelly processed across, okay, multiple, okay, machines. Okay, this is called data parallelism. This is actually in bracket, guys. We can call it as a massively, okay, parallel processing. Massively parallel processing means massive volumes of data can be processed parallelly across the multiple machines. And one more advantage of this massively parallel processing is, guys, even if unfortunately, guys, there are multiple machines, sir, in distributed computing, guys, remember, in distributed computing, you have multiple machines. Sir, multiple machines are participated in distributed computing. In distributed computing, multiple machines are participated in computing the data. Computing the data means processing the data. Yes, if unfortunately, if one machine is failed, guys, come on, what I'm saying is, if unfortunately one machine is failed, yes, that machine related work, that machine related processing will be given to other machines. If other machines are already too busy with the data processing, even you can launch a new machine. Yes, guys, what are the terms I'm saying? Could anybody can tell technically what the terminologies are called? Anyone? See, guys, what I'm saying is, if unfortunately, if one machine is down, I have 10 machines, I have 10 computers, the data is distributed and processed across the 10 computers. Yes, if unfortunately, if one of the machine is down, guys, if it is down, then that machine related work, yes, will be, okay, given to automatically. You manually know automatically. Yes, so somebody is monitoring the health of every machine. Somebody is monitoring, someone monitoring the health of each and every machine. Yes, that's called, guys, health monitoring of the machine. Health monitoring of the machine, or diagnose, okay, diagnosis the health of the every machine. If one machine is down, that machine related activities or tasks will be, okay, given to other machines. Yes, and guys, could you please tell me the machine related tasks given to other machines? If the machine is down, shut down, then guys, tell me what that activity in computing world we call, or in data processing world. Maybe you know this terminology, I think.
Scale up and scale down.
Yes,
Health
yes.
check.
No. Scale up, scale down is
Load
wrong.
load
Scale up,
balancing.
scale down is wrong. What else? Yeah,
Load
Jilani.
balancing.
Of course, load balancing will be there. I'm talking about machine
Health,
failure. If you have 10 machines, if unfortunately one machine is failed, yes, suppose say machine one have, okay, a task. Let us say filtering the data is the task. Data cleansing is the task that is given to machine one. Okay, some part of the data is processing. Part of the data means partition. Would suppose machine one is unfortunately failed because of some issues. Then what the task which is assigned to the machine one,
Backup.
okay, will be given to the other machines. Yes, come on. The tasks which are assigned to the machine one will be hand over to the other machines. Yes, that
yes.
is, yes, that is actually called as, guys, in a real time, we call it as, guys, okay, um say on failure of the machine. Yes, on failure of the machine. Yes, hand, we can call it as hand over the tasks, or distributes the task to other machines. Okay, is, okay, known as, guys, okay, on failure, okay, resilience means on failure of the, okay, things, and hand overing the task to others. Failover, failover, or resilience. Okay, so, and see, guys, it supports, okay, And suppose, sir, I have a 5 machines. Okay, sir, I have a 5 machines. Out of these 5 machines are fully busy with the tasks. Okay, guys, fully busy with the tasks. But again, suddenly volume of data is spiked or increased. Okay, guys, you tell me, and what you guys will do. Suppose, say, example, in my cluster, a cluster is nothing but a group of machines. A cluster is a group of machines. A cluster is a group of machines. There are, say, example, there are 5 machines. All the 5 machines are, okay, distributed with parts of data called partitions to process the data. Okay, and suppose if these 5 machines are fully busy, but suddenly volume of data got increased, how to handle?
Is it in the monolithic or in distributed?
No,
Yeah.
no. See, guys, we'll go for scalability. Now,
Scale.
Likita has just a few minutes back, okay, scale down, scale up, okay, or scale out. Okay, now you can add the one more machine, or you can add the few more machines. Okay, come on, this is called scalability. Very important features are compulsory. This is a question. Okay, this is a question comes. Why I'm telling, guys, please listen me. Of course, you are very new to, okay, these batches. In the last morning 7 a.m. batch, I've completed around 45 days back, and morning 8 a.m. also. These two batches. In these two batches, almost okay, 11 members have written the certification, guys, and Databricks associate certified data engineer. They have written the certification. All the 11 members in a single attempt, they have completed the Databricks, okay, associate data engineering certificate. In a single attempt, they have completed. Of course, in that there are some people, they want to keep experience completely a fake, but most of the real time already working professionals having 7 years or 8 years of an experience in that. Okay, and out of 11 members, I just only few people only talk with me after completion of certification, and very recently. Okay, because of 45 days back completed means they have around Dasara festival. Before that, they have written the exam. In that also, this question has come. Okay, what is a scale out? Generally, in the classroom, we are going to discuss with the different terminologies, but there they asked about scale out. Okay, and so scale out is nothing but, guys, scale out is nothing but adding a new machine to the existing cluster or to the existing machines, depends on the volume of data. Yes, sir. In any cluster, there are inbuilt algorithm to calculate the resources required to handle the volume of data. Okay, there is a sudden spike in raising the volume of data. At that time, this algorithm will take care of determining whether existing machines are can handle this data or any new machines to be launched. Yes, if you launch new machines automatically, that is called actually, and simple basic terminologies, guys, horizontal scalability. Horizontal scalability, that technically in the industry we call it as a scale out. Scale out. Yes, scale out, adding new machines if the volume of data increases to speed up the parallelism or to speed up the data processing. If volume of data is down, it automatically shut down the machines or down the machines. This is called, guys, dynamic scalability. Dynamic scalability and auto scalability. Auto scalability. Dynamic scalability or auto scalability. Okay, so every machine, generally in the industry, guys, every machine is called as a, guys, a node. Actually, machines are called as a nodes. Please try to adopt. Okay. Anyway, when I'm discussing Databricks, okay, when I introduce Databricks, there I will discuss what is Spark architecture, what are the different types of nodes like driver node, worker node. A node is nothing but a machine. Yes, or you guys can also call simple in a layman language a computer with some hardware capacity. Sir, main a machine is capable means the hardware capacity, how much hardware you how much hardware, how much powerful hardware you provision. Based on that, the data can be processed. Okay, so simply, guys, machine is nothing but a node. Okay, and here what are the data? Okay, see, data which you are collecting, guys, come on. Data which you are collecting, that's called incoming data or source data. The source data gets divided into small chunks called partitions, and those partitions are distributed evenly or load balancingly across the machines, and each machine will parallelly process the data. That's called parallelism, sir. And some few points, sir. What is a machine failure handling can be done? Come on, anybody? Come on. How to handle the machine failures? Come on. Yes. If the machine is failed, machine failure.
If the data to another
Fault tolerant.
Another machine. Can we call that is
Application.
a? Can we call that
Resilient.
feature is called as a fault tolerance? Come on.
Fault
Supports fault
tolerance.
tolerance. Come on, guys. Technical word on failure. On failure, how the system is resilient. Okay, so guys, here and supports and distributed computing, main advantage is, guys, supports. Okay, fault tolerance. This what the technical word, fault tolerance. Fault tolerance means and on handling machine failures. Okay, so here how machine failures can be handled. Machine fails. Okay, or in sometimes due to network issues also the machines will be failed due to some network issues. Okay, and so I can also write, guys, okay, machine or node. You can also use the word, guys, node failures. How to handle the node failures? That's called fault tolerance. If the one node is failed, that node related tasks are given to the other nodes. And one more, the beauty of distributed computing or distributed data processing, one more advantage is, guys, supports come on, supports scalability. Supports scalability, guys. Scalability. And Amaresh, Likita, Padma, yes, Aruma Devi, Vamshi, anybody can say, Manohar, Kumar, anybody, Josna, can anybody say what is scalability? This is very important, sir. Even in the certification, you can expect this question.
Adding few more machines.
Yes. Okay.
Adding nodes
Yeah, very good. Adding nodes.
and
So
removing not.
yeah, very good. Very generalized way. Let us will put it in general definition. Increasing the capacity of the system. Come on. Yeah. A system. A system has a group of machines. Now the system capacity we are increasing by adding more machines, or by adding existing machine configurations, by increasing the existing machine configuration. Yes. So scalability, sir, make a question yourself. I'll give scalability definitions, guys, and see better. I'm giving increasing capacity of increasing capacity of an, okay, uh, capacity of a system. Simply say, you guys can ask the question, a system, what can be the system, what can be the system? Okay, sir, anybody?
Machine itself,
Yes,
the
very good,
nodes.
very good. Yeah, yeah. General, sir, very generalized. Okay, slowly
Cluster.
technical terminologies will adopt it. Okay, that's what I'm saying, guys. And you guys, nothing to worry. I have given the course duration of 8 weeks or 10 weeks, but that also I don't keep in my mind. I don't know how much time it will take, but everything I will cover, everything. And as per the syllabus pattern, it has to be so. I will take certainly time, but everybody should technically, you should be very strong. And I always give the priority for technical terminology adoption in the project. Tomorrow, if somebody asks you, explain the project, explain the medallion architecture. So all the terms are very, very, very important. Scalabilities are node terminology. And what do you mean by distributed computing or distributed? Yes. Okay. So scalability, okay, in simplest terminologies, guys, in simplest terminology, in simple terms, scalability means, okay, scalability means, okay, how an analytical system can grow smoothly, can grow, how a system, analytical system can grow smoothly. Yes, means, let us say, when the volume of data increases, how the analytical system can handle the, okay, how analytical system can handle the data processing queries as growing very smoothly. Growing, scalability means growing. Okay, so here remember, and scalability in big data analytics refers to ability of analytical system to handle increasing amounts of data or increasing amounts of users or the workloads efficiently. Anyway, I'll give the definition separately that, and in a simplistic terminology, in a simple terminology, guys, scalability means increasing the capacity of an analytical system. Better, right? An analytical system. As per our data engineering point of view, see, analytical system. Okay. And one more thing, sir. In distributed computing, one more very important term you should know, guys. Supports. Okay. Elasticity. Supports elasticity, guys. What do you mean? Supports elasticity. Elasticity means, guys, remember, your distributed data processing systems even supports elasticity. Not only scalability, elasticity means when the volume of data increases, it's okay, analytical system capacity increases by adding more machines or more nodes. Okay. If the volume of data is down, then automatically down the machines and shut down the machines, means unnecessarily we are not consuming any machine resources. When the volume of data increases, increase the resources. When the volume of data comes down, and down the machines. That is called elasticity. Okay, means increasing or contracting the system resource utilization. That's called elasticity. And even, sir, distributed computing systems even supports elasticity. Main advantage is you can save the analytical system resources, and by saving analytical system resources utilization, you can even save the cost. Yes, this feature actually called as a dynamic. Guys, hair bands. Guys, take an example of hair bands. So hair band have, when you apply the more force, hair bands, when you apply the more force, it will increase its length. Yes, and once you apply the less force, it will contract. Yes, so, and increasing and contracting. Okay, that's called elasticity. Even distributed computing systems supports even elasticity. And what is scalability? What are the different types of scalabilities, and which type of scalabilities are supported by and distributed data processing? And what is elasticity? What is the difference between scalability and elasticity? Here, these are all things, okay, in continuation class. Sir, now here, and these points I'm writing, guys, only these points just I mentioned, but still a lot of points are there in distributed processing. Wait. Now, as per that, sir, in monolithic data processing means only single machine involved, only single machine involved in processing the data, and recommended for low volumes of data to process. Clear. And now tell me, uh, when comparing with monolithic and distributed computing, is a monolithic supports scalability? Come on. Yeah, come on, guys, you know very well.
No.
No show pressure. Okay. But I say yes, it supports. But
It cannot
yes,
add system, but it can
yeah,
increase
yes,
capacity.
yes. See, you cannot add a new machine. Why? Because it's a single machine only. You cannot add a new machine, but existing machine power can you increase? Suppose in a single machine you have a 8 GB RAM. Shiva, remember? Shiva Prasad, remember? In a single machine you have a 8 GB RAM. Now 8 GB RAM can handle processing the low volume of data. Suppose suddenly the volume of data is increased to 10 GB or 20 GB. Okay. Ultimately, load on the 8 GB RAM increases. Now, can I add a 4 more GB to the existing 8 GB? Or can I add a one more 8 GB RAM? Come on. Yes, you can add it.
Yes,
You
Yes.
yes,
can
like
add
that.
Yes.
you can add
So,
Vertical
it
scaling.
very good. Vertical
on the
scalability.
vertical.
Very good, guys. Vertical scalability. That's the reason. In tomorrow's class, I'll elaborate more. What is scalability and types of scalability? Yes, like vertical scalability, horizontal scalability, hybrid scalability. Of course, hybrid in the sense the mixing of vertical and horizontal. A vertical scalability is called as a scale up. Scale up. Sir, actual technical word is scale up. Yes, increasing the capacity of the existing machine is called as a scale up or vertical scalability. Adding a new machine is called as a horizontal scalability, which is called scale out. Scale out. Yes. So here, and monolithic, sir, I'm writing just a few points when comparing with the distributed computing. Okay. So supports, okay, vertical scalability. Okay. Bracket, I'm writing scale up. Actual terminologies, guys. This you need to adopt, guys. Scale up only you try to, please try to adopt the terminology called scale up. Okay. Scale up. Answer. One more point. Okay. Is it monolithic compute supports fault tolerance?
No,
No. Yes.
because
Single
single
machine.
machine.
Yes. Single machine. If it is a failed, single machine, if it is failed, yes, you need to restart the process from the very beginning. You need to restart the data processing from the very beginning if the machine is failed. But in the case of distributed computing, as since you have multiple machines, if unfortunately if one machine is failed, other machines will take up the work without disturbing the existing processing. Okay, that's called fault trends. Okay, and here no fault tolerance, does not support the fault tolerance. Yes, and see, that's called zero fault tolerance. Okay, so no fault tolerance. Okay. Okay, so anyway, and sir, everything day one, maybe for you it's a technical demo, first technical part demo. Say take exam, it's a demo only. Okay, because Saturday I just explained what is what the duration something. Okay, but first technical. Okay, but whatever I'm saying here is everything is important when we enter into the main course curriculum. Main curriculum when we enter, and that's very, very important. Everything you will recollect. Yes, on the day of 20th, Venkata has discussed these points. It's correlating these points with the actual subject in data bricks. Okay, so you can slowly understand. It's a very first class. Okay, so here recording session I'm stopping, guys.